Section 7.3, Simple Interest. Interest is a fee paid for the use of money. Either you're paying interest on money that you've borrowed, so you need to pay back more than you initially borrowed, or if you're investing money, maybe that money is gaining interest and you're being paid the additional money onto the money you invested. Simple interest is a one-time percent. Compound interest, on the other time, is a percentage of an original amount, as well as a percentage of the new amount, including previously calculated interest. So your interest may be paid more often. Maybe you have interest added to your account every year. So now you have more money in your account than you did originally because you have the original amount plus the interest. And then at the end of the next year, you'll be paid interest off that larger amount that you now have in your account because it includes some previously paid interest. For simple interest, we need the following information. First, we may need to know the interest, which we'll call I. Again, this is the fee charged for the use of money. We also need to know the principal, which we call P, which is the amount of money borrowed or placed into a savings account. The rate, which we use a lowercase r. This is the percent of the principal paid for having money loaned or earned for investing money. Unless otherwise indicated, rates are given as a percent for 1 year. And also, when doing calculations, we like to write our interest rate in decimal form. The time or the term, which we indicate by T, this is the length of time that the money is being borrowed or invested. Now, when the rate is given per year, our time also has to be written in years. So if you were given time in terms of months, you need to convert that into years. And the future value, which is denoted by a capital A, sometimes I think of this as like the amount in the account, so the big A. This is the amount of the loan or investment plus the interest paid or earned. Exercise 1. An account is opened with a deposit of $300 and earns 2% per year in simple interest. That means that after the end of the first year, 2% of the current value will be added to the account. How much interest will be earned? Well, I need to figure out what is 2% of 300. So translating this, I have n equals 0.02 times 300. And if you multiply 0.02 by 300, you get back 6. So the amount of interest that this account earns during that 1 year is $6. If we earn $6 in 1 year, how much would we earn in 5 years? Okay, well, if we earn $6 every year, and we're doing it for 5 years, then at the end of 5 years, we're going to have earned $30. Well, what about in T years? Okay, well, when it was 5 years, I just multiplied the amount by 5. So if it was T years, I would just multiply the amount by T for whatever T may be. So T may be 10 years. So if it was 10, I'd change T into 10 and I would have $60. If T was 7, I'd change T to 7 and I'd multiply and have $42 and so on. So now we want to use parts A and B to write a formula for finding the amount of simple interest earned on an account with principal value P, interest rate R, and time T. Well, we saw, if I go back to the first one, that I earned $6 when I multiplied my original amount by the interest rate, and this was for 1 year. We're looking in part B, I earned $30 when I multiply my original amount times my interest rate times 5 years. So I didn't show that this was actually the principal times the rate, but that's exactly what we did to get 6, right? We did the principal times the rate, and it gave us back $6. So this 300 times 0.02 is just the 6 that I have above. Or using these variables, I can see that the interest is equal to the principal amount times the rate times the amount of time, or I equals PRT. One way I remember this is I say like I party or I pretty, some sort of word that looks like PRT, and it helps me remember the formula. Formulas for computing simple interest and final value. This is the formula that we just found in part 1, which is that the interest is equal to the principal times the rate times the time, or I equals PRT. Now, if we use this to figure out I, which is our interest, then to find the future value, either that you need to pay back or that your bank account or savings account now has, is going to be the original amount that you invested or borrowed plus the interest that you are paying or earning. So A, which is our future value, equals our principal plus our interest. And that's exactly what we have here too. So notice if I distribute this through, I get A equals P times 1 plus PRT. But what is PRT? Well, PRT is just I. So this is exactly the same as A equals P plus I. So these two formulas are saying the exact same thing. You can remember whichever one you like. I like to usually just think of it as the future value is equal to the original amount plus my interest. Okay, exercise 2. Find the simple interest and future value for a loan of $2,400 with the given conditions. So the first one, we have 2 years at a rate of 5.5% per year. Okay, well, the simple interest formula is I equals PRT, and we're trying to find I. So I have I equals my principal, which is $2,400, times my rate, but I need to write this as a decimal, so we've learned how to do this. That's 0.055, times my time. And remember, time has to be in years, and this is given to us in years, so times 2. If you plug all of that into your calculator, you'll get back $264. Now, we were asked to find the simple interest as well as the future value. So remember, future value is just the amount that you originally invested or borrowed. So this is a loan, so we borrowed our principal of $2,400 plus your interest. And for us, our interest was what we just found, which is $264. So the future value of our loan that we need to pay back is $2,664. Part B, we are doing the same exact problem, but for 9 months at a rate of 9%. So our principal hasn't changed. Our rate has changed, so I'm going to change this to a decimal, 0.09. And our time has changed to 9 months. You do not want to write 9 here because remember, the time needs to be per year. So I need to figure out how can I write 9 months as some part of a year. Well, a year is 12 months, so I have 9 out of the 12 months. Or simplifying that fraction, I get this is 3/4 of a year. So I'm going to multiply by 3/4, or if you want, you could write 0.75. I'm going to show you how we could do it as a fraction though. So one thing you could do if you want to simplify this is you could simplify the common factor of 4 with the 2,400 and the 4 in the denominator, right? Because you can think of all of these as fractions over 1. Right, and then I could simplify things that match in the numerator and denominator. Or you can multiply straight across the numbers in the numerator and then divide your answer by 4. So why don't you try one of those in your calculator right now so that you can compare your answer with what I'm about to get. And if you put that into your calculator, you should end up with your interest being $162. If you didn't get 162, try to type it into your calculator differently, or maybe you're missing some sort of a parenthesis somewhere. If you wanted to write it all in one step, you could do parentheses 2400 times 0.09 times 3, close parentheses, divided by 4, and that should give you back the 162. All right, and then our future value, we just need to add this to our principal, which was 2400. So for a loan with these conditions, I would need to pay back $2,562. Exercise 3. A family wanting to open a restaurant borrowed $32,500 at 6% simple interest for 1.5 years to renovate a restaurant location. Find the interest, future value, and the monthly payment. I would like you to try problem 3 on your own. Pause the video and at least try to find the interest and the future value. And then come back and check your work. And you should have got $2,925 for your interest and $35,425 for the future value of the loan. Now, maybe you tried the monthly payment on your own, which is great, but if you didn't, what we need to do is we need to figure out how many months they had this loan for. Well, it's 1.5 years, and a year has 12 months, and half the year is 6 months. So in total, they have this loan for 18 months. So all I need to do is to divide the future value of my loan by the number of months that I have it for. So that's 35,425 divided by 18, which gives me that their monthly payment will be $1,968.06 per month. Exercise 4. Douglas has always wanted to buy a boat. The interest on a loan he took out for his boat was $11,812.50. The money was borrowed at 6.75% simple interest for 60 months. Find the principal. So the last 3 sets of problems we did, we were finding the interest, so we were looking for I, but in this case, we're asked to find the principal, which is P. So here's our formula. It says it's simple interest, so we know we're still using I equals PRT. But this time we know I, or the interest, is this 11,812.5. We don't know P. We know the rate is 6.75%, so changing that into a decimal, we have 0.0675. And we also know that it was for 60 months. Again, this needs to be in years, so we need to divide 60 months by 12 months, because there's 12 months in a year, and we're going to get that this is 5 years. Plugging these numbers on the right side of your equation into your calculator, you get 0.3375, and this is still multiplied by P. I just kind of rearranged it, but you know, multiplication is commutative, so I can rewrite the order. And now to solve for P, we just need to divide away that 0.3375. And 11,812.5 divided by 0.3375 is 35,000. So Douglas's original amount of the loan he borrowed was $35,000. So what we can see is that boats are very, very expensive. Just think in total, not only did he have to pay back $35,000, he also has to pay back this $11,812. And if you ever heard that old saying, it says, the two best days of owning a boat are the day you buy it and the day you sell it. Discounted loans. Sometimes the interest on a loan is paid up front by deducting the amount of the interest from the amount the bank gives you. This type of a loan is called a discounted loan. The interest that is deducted from the amount you receive is called the discount. So exercise 5. Mildred got a $5,000 discounted loan for 3 years at 6% simple interest. Find the discount. Well, the discount is the interest that's deducted, so we just are asked to find the interest. Plugging in what we know. And plugging this into your calculator, you should get back $900. So the discount for this discounted loan is the same as the simple interest, which is $900. So part B says, find the amount of money that Mildred received. Well, we saw above that for a discounted loan, the interest is subtracted from the total amount before the person is given the money. The original amount of our loan was $5,000, but the bank is going to subtract off the discount, which was $900. So the total amount of money that Mildred is going to receive that she's borrowing is $4,100. Part C then asks us to find the true interest rate. Because she technically didn't get a loan for $5,000, she got a loan for $4,100. Again, we have the formula I equals PRT. We know the interest that she paid because they took it off of her loan already, which was $900. But the actual amount of money that she was given was only $4,100, not $5,000. So we want to figure out what interest rate is that to get $4,100 for 3 years and having interest of $900. Multiplying the 4,100 and the 3 gives us 12,300. And then to solve for r, I just need to divide away that 12,300. When you divide 900 by 12,300, you get 0.073. And changing this into a percent gives us an interest rate of 7.3%. So sometimes people consider these discounted loans to be deceiving because technically she paid an interest rate of 7.3%, even though it's advertised at 6%, because they took this interest off the total amount that she was given at the beginning.